Alright, today's video is going to cover solving systems of linear equations with substitution. The exact same skill as the previous lesson. However, the equations that you're solving are a tad bit different. So let's go ahead and connect what we're doing today with what we did yesterday. So yesterday we solved using substitution, and when we substituted, what we ended up doing was solving a multi-step equation. We got something like 3x plus 3 times x minus 5. We substituted that in, and we ended up solving a multi-step when we had our systems. Well, today what you're going to do is you're going to solve a variables on both sides. So you're going to end up substituting and getting something that looks like 3x plus 2 equals negative 4x plus 5. Okay, where the substitution part stays the same, but the equation that you're solving as a result is a little different. So just one main mistake that we see students make, it's writing the solution backwards. So backwards solution. And what I mean when I say that is you'll get something like x equals 5 and y equals negative 3. And then when you write this as a coordinate point, because the solutions to systems are coordinate points, I see students write negative 3 comma 5, where they put the x or the y before the x. This is incorrect. Remember, you write coordinate points x, y. So it's got to be x, y. Now, the steps for yesterday are the exact same, or from the previous lesson are the exact same today, so we can just go ahead and get into some examples. So example number 1, and these two equations are given to us. Step 1 was to solve for one of the variables in one of the equations. Well, if you look at both of the equations right now, they've got both variables solved for. They got y solved for, or they got y solved for. So step 1 is already complete for us. So we can go ahead and move into the second step, which was to substitute the expression of one of the expression of the solved variable for the variable in the other equation. So in this case, all we're really doing is we're just going to set them equal to each other. So I'm just going to write that here because it's an easy way of thinking about it. If both of the equations are solved for the same variable, you're just going to set the expressions equal to each other. So the expression that y equals in the first equation is 5x plus 16, and the expression that y equals in the second equation is negative 7x minus 20. What's the justification here? We just substituted y. Now, here you can see their equations, variables on both sides, and then on each side we have number, variable, and then some other number, variable, and then some other number. So the strategy here is to select the number in front of the variable that is larger. Now, you don't have to, but this saves you from having to deal with a lot of negative numbers. So 5 is larger than negative 7, so the number side is the right side, and I'm going to go ahead and start by eliminating the variable on the right side by using inverse operations. So I can add 7x here, and I'm going to add it here. What are we doing to both sides? We're adding, so we're going to use APE as the property that justifies it. So these go to 0. What we're left with on the right side is negative 20. And then we can go ahead and combine these x terms on the left side. 7 and 5 combine to 12x plus 16 we can just bring down. Now we've got the variable on one side. We can go ahead and start eliminating these numbers. So the easiest number to eliminate is the one that's by itself. The inverse here is subtraction, minus 16, minus 16. We're subtracting to both sides, so we're using SPE. These go to 0. We're left with 12x equals negative 20 minus 16. So you're subtracting from debt. So you're going further into debt. Negative 20 minus 16 is negative 36. Now we can go ahead and finish this out by dividing both sides by 12. And what we get for x is x equals negative 36 divided by 12 is a negative. 36 divided by 12 is 3. So negative 3, what did we do to both sides? We divided to both sides. Now we can do step 3. We solved for one of the variables. So now we're going to substitute this negative 3 for x. Okay? And Either of these equations is fine to use because both of them are already solved for y. All we're going to have to do is simplify anyways. So I'm going to go ahead and use the top equation. Y equals 5. X is now represented by 3. That's the value, or negative 3, sorry, plus 16. What did we just do? We just substituted x. Now we can go ahead and simplify. So 5 times a negative 3 is a negative 15 plus 16. I owe 15. I have 16. I have enough money to cover off my debt after I pay the 15 I owe. I've got 1 left over, so y equals 1. Now we can go ahead and write our final answer. We know that x is negative 3, y is 1. So our answer here, we should have simplified for this last step, and then our answer here is negative 3, comma 1. I'm going to do this all in white, so these are given to us. So step 1 is to solve for one of the variables. Well, they're both solved for already, so step 1 is already complete. We can go ahead and step 2, and we're just going to set equal. So we've got the expression here, 3x minus 5 equals negative 4x plus 9. And you can do this because, remember, both of the variables are solved for. That's why we're setting them equal. What did we do? We substituted y. Now we've got variables on both sides. Again, let's choose the side with the number that's larger. So positive 3 is larger than negative 4. This is the number side. I'm going to start by eliminating the variable on the number side. So I'm going to add 4x. I'm going to add 4x. These simplify to 0. These simplify to 7x. Bring down the negative 5. And we're just left with 9 on the right side. We added to both sides, so we're going to use APE to justify. Now we can start solving this two-step. So we're going to add 5. That's the inverse here. Add 5. Our justification is APE. These simplify to 0. We're left with 7x equals 9 plus 5 is 14. Final step, the numbers being multiplied, so the inverse here is to divide both sides by 7. DPE is our justification, and we can go ahead and simplify this. These simplify to 1, so we're just left with x equals 14 divided by 7 is 2. Now step 3, we're going to take the value we now know for x, and we're going to substitute it in. In the previous example, I used the top. In this example, I'll just use the bottom equation to show you it does not matter. So negative 4 times x is now 2 plus 9. Let's go ahead and write we substituted x, and now we can go ahead and simplify. So negative 4 times 2 is negative 8 plus 9. Negative 8 plus 9 is a positive 1. You don't need to write plus 1. Alright, I just wrote a negative because I made a mistake, so I changed it to a positive. Our answer here as a coordinate point is 2 for x and then 1 for y. That's correct. Final example for today. So you can see here we've got two equations, but this one does not have a constant. So step 1, we know by looking at it, is already done for us. We've got both of them. So step 2, we're going to go ahead and set them equal to each other. So 2x equals 7x plus 5. This was given to us. What did we just do? We substituted y. Now, normally what I would say is let's make this the number side and this the variable side. However, we're not going to do that in this case because if you look at the left side, there's less numbers. So sometimes it makes sense to make the side that has less numbers your variable side. It ends up saving you an extra step in the end. So you'll see that as we go through this example. We're going to go ahead and start by eliminating the number on the variable on the number side, so minus 7x. What did we do? Subtracted. SBE. These go to 0. We're left with 5 equals 2 minus 7. Well, 2 minus 7, I do not have enough money to cover the $7 I owe, so I'm going to owe money. How much am I going to owe after I pay the 2 I have? I owe 5, so 5x. And now you can see that the last step here is to divide. So we saved an extra step by choosing the left side instead of choosing the right side. The right side people would have done an extra step. If they want to do an extra step, we'll let them do an extra step. We're just going to take the easy route for now and save ourselves some time. So we've got x equals 5 divided by negative 5 is a negative 1. Now step 3, we're going to go ahead and substitute. So substitute x. and it makes sense to substitute it in the top one because it's got less numbers to simplify. So we got 2 times x is now negative 1, and now we can go ahead and simplify. 2 times negative 1 is a negative 2, y equals a negative 2. We've got our answer because x is negative 1, y is negative 2. That's our answer. If you have any questions on the homework, please message me in Schoology or consult one of your classmates. Good luck on the homework.